Welcome to today's webinar, Component Library Management in OrCAD X, How to Set Up Your Design for Success. I'd like to introduce our presenter, Roger Chin. Roger is an electrical engineer based out of Princeton, New Jersey, and has been with EMA since 2013. He's a field applications engineer focusing on component library management, design data management, SPICE simulation for circuits, and power integrity. Assuming we have time at the end of the webinar, we'll field some questions in a formal Q&A. Thank you for your attention, and now over to you, Roger.
Thank you, Shannon, and thank you everybody for attending our webinar today. We're going to give an introduction and then hopefully a little bit of a deeper dive into OrCAD X CIS. So OrCAD X is a very new and powerful version of the software that's come out in the last year, and we're going to focus specifically on the CIS portion of that for our webinar today. With the OrCAD X license now, we have CIS included. And CIS is our component information system. This gives you a centralized flow for which your design team can see your parts, have a searchable, sortable environment to find the exact component you need, and have direct access to preview your schematic symbols, your footprints, and the approved manufacturer part numbers that you have, and their alternates right inside of the OrCAD environment. So it really is a big upgrade from the traditional OrCAD flow. You now have all of these features in every single OrCAD X license. You don't have to go and get CIS separately now. It is a part of OrCAD X and included in every license there. So the CIS user interface is very powerful. It gives you access to a lot of data. You can go and set up a part tree and organize your components to exactly the way you want. The database also lets you see the symbol, see the footprint, gives you access to all of that information in one space. So you don't need to step outside OrCAD. You don't need to learn any database management. It puts everything right in front of your design team. And all of these fields can be customized and populated with the data that you choose internally. When we dive into the world of CIS, we're no longer just dealing with individual CAD models, right? You can see up here in the top left, we have CAD models, of course. We have footprints. We have 3D step models. We might even have simulation models. But it's not enough to just have models and have your users have to look into libraries, place parts. That's the traditional OrCAD flow, right? Now we want to centralize it so you actually have part data. You have part numbers, you have approved vendor lists, you have where used, you have history, you have categories, you have all your electrical parametrics, you have access directly to the data sheet. All of that is consolidated into the CIS environment. So you don't need to, have each capacitor have its own CAD model and then put in a description to every single symbol on your schematic library. Now you can reuse symbols. You can tie all of this data, all of these files together into one central database where you have unique part numbers, you have engineering part numbers, manufacturing part numbers, and you can go and search and sort by any of that data. So as we mentioned, CIS is all about part number instead of symbols. We're not going to look for symbols individually. We can still if we want to, but now we have a part number scheme. It will only allow one unique part number at a time, but then you can have multiple manufacturer part numbers tied together to that engineering part number. And you can set the order of your manufacturer part numbers, your primary part you want to use. If you can't buy that one, you can show in your BOM, this is the alternate I want to use instead. And you can even see here, you can give approval fields. You can say this is an active manufacturer part number. This is the data sheet for it. This part is RoHS compliant. All of that data now is in front of your design team. So you're not waiting, you're not building up your design and then reacting to using bad parts. You have the agency to find that data right off the bat. For those of you who are used to the traditional OrCAD flow, where you have to look for each symbol on its own, you might organize them into different OLB library files. We have now added way more organizational structure to it. You can have a database here that we're seeing on our right, and you can have multiple tables. Each table can have unique parts and unique fields, and then you can have sub-part types where you're organizing the structure you want. And you can customize that. You can say, I care a lot about the exact package size of my capacitors within what dielectric type. As you can see on the right here, we organize our database that way. You can change that to match how your team wants to find parts. You can also search for parts. You don't have to now just look up the name of the schematic symbol, right? You can look exactly for a part that has a certain text in the part number, a certain tolerance value, and you can do some operators upon the value. You can say greater than or less than or equals to, and you can filter out exactly the type of components that match your search criteria, and then save that search criteria for future use so that you don't have to go and set this up every time. Having this ability to build up our schematic from that database and have parts that we trust, that we're confident in, that we're reusing in other designs, that's the first key of CIS, right? But it's not enough to just build our schematic better. We also need to be able to keep our schematic in check with our component database. So with CIS now, you have the part manager where you can come in and you can see exactly what parts are in sync or what parts need to be updated. On the right here, you can see this U2 part on my schematic has now been flagged by my database as obsolete. It uses a part number to synchronize that schematic symbol from my open design to the central database. So that really gives you one area where your whole team can look to and can have confidence in the part data, which will give them confidence in the design that in the board that you're pushing out, right? You can check for any differences. You can update each symbol to match the database, or just flag the ones in a legacy design that are out of date. And then you can select multiple symbols to update them at the same time in one action to match the database, or swap out for another part altogether. It can even do some design cache checking and tell you, hey, this part, all the properties match, but your librarian or your team has updated your schematic symbol, so your local cache is now out of date with the source package. Our ideal outcome in this part manager is to have everything in green, right? You want a part that's not only approved, but current. So that means that the part number on the schematic, on that placed part, has an exact match that's approved in the database, and every property that we transferred from the schematic to from the database to the schematic is up to date. So anything that doesn't reach that state, your schematic part manager notifies you of that in CIS. You can take your OrCAD design and check and see, hey, if I have a package that's out of date, that's that local symbol being out of date, it'll flag it in red in that CIS part manager. If I'm using a part that has all the properties matching, but the part number hasn't been formally approved, it'll flag it in yellow. So you'll see we're now getting into the idea of having a 10-part introduction process. Your team can go and put parts in their design that they might want to use, but hasn't been formally reviewed or approved yet, right? So it gives you a whole structure for which you can start checking your designs and having confidence in releasing out a design to a board when everything is approved and current. For those of you who are used to the traditional OrCAD BOM, CIS is going to be a huge advantage in the BOM functionality. You don't have to save the header and type it in text. You don't have to know the property names and have to type each field. You can now actually use an user interface to search for a property, to pull that property into your output format on the right, and then order it in specify the exact order you want those properties to show up in your BOM. And even better, you can now save that template and reuse it in the future. You don't have to set up a BOM each time just to get what you want out of your board. And now that we mentioned, we have a database, there's multiple manufacturer part numbers. I want that kind of data, the costs, the distributor information, maybe the obsolescence if I have that information. I want that to show up in my BOMs, right? We can have that direct access to the database, pull that data, and show all that information in one BOM using the CIS build materials. And we'll talk about variants in a little bit more, but with CIS now, you can have multiple variants tied to one design, and you can pick whichever variant you want to output the BOM you need. So here's an example of the kind of power you can get. You can take your design and you can push out a BOM here where for my C1 capacitor, I can see the value, the description, and then I can start seeing things like my alternate manufacturer part numbers, right? I can see my distributor information as well, and I can make this horizontal additional columns, or I can make them rows like I have seen here. So you now not just have a BOM that's functional, you actually have a BOM that can give you confidence in the design in the board that you're building. So on the topic of variants, again, CIS is huge in that it can take one DSN file, that OrCAD schematic design, and give you the ability to now save as many variants upon it. And that means that you can take that design, as long as you're not making a big connectivity change, you can do changes like swap out parts for a different manufacturer part number, or you can set parts as do not populate. So here on the right, what we're seeing is the variants managed inside our CIS part manager. And you can see on the bottom, we have R5 and R4 set as do not populate, and R1 and R2 set as alternate manufacturer part numbers. So we're making a change, but only saving it for that variant. So then we can push out a different BOM from the same core design. You can even view the changes of those variants in your OrCAD environment, and you can print this out as a PDF and an intelligent PDF as well. So here, R4 and R5 are color-coded to show that they're set as do not populate for this variant, and R1 and R2 are color-coded to show you that they're set to a different manufacturer part number. And of course, you want the confidence to be able to say, hey, this variant is susceptible, right? It doesn't cause a change in any board functionality. It doesn't cause a need for me to have a different footprint. So I can see here for R1 and R2, in brackets, I can see the change in the part numbers. For R4 and R5, I can see that now they're set as do not populate. But over on the right, I have confidence that the PCB footprint is the same between each of my variants. So that means for one board, I can support these two different variants together. So to continue, we've really talked about the big changes that this new OrCAD X license gives to you, right? You now have all of these capabilities that really make it a more modern way of not just building, but having confidence in the designs you push out. But CIS opens a world that you need to actually build a database for, right? It's not enough to have your schematic libraries and simply have symbols. You have the need for that part data, right? So in this table, we're trying to emphasize to you, before CIS, everything was managed individually, right? You have your OLBs, you have to know the symbol names, you have to put your libraries on some shared drive probably. If you have any kind of supply chain data, you're grading it manually, you're applying to each symbol. If your engineers are each building their own libraries, it's dependent on them to have the naming format correct. Some people might call it MPN, some people might call it manufacturer part number. That will lead to different outputs and different BOMs, right? You can't search by parametrics, you can't have multiple symbols you can pick for one part. You can't do variants in the same design. You can't have BOM templates, nor can you pull data from an enterprise system into your CAD libraries. So CIS gives you a yes to all of that, right? I can now have access to all of that data. I can really set up a whole environment for reuse. And I can share those parts within my whole team and have that data be driven from one central database. But CIS itself is not an actual database, right? It's the upgrade to OrCAD that gives you the ability to access the database. You still need to actually have a database structure, a schema of tables and fields. And from our experience, this is not a trivial task, right? Customers might have to in our experience, have built this up themselves. And it does take time. It's a manual effort. You need to create the whole schema. You need to figure out how your team likes to do things. And if you build your own, access database, you need to have somebody be in charge of it, somebody know where that spreadsheet essentially is, and only one person can go and change it and make sure they don't mess it up for the whole team. So everything is pretty manual if you do it from scratch yourself. And we've had a lot of customers come to us asking for help. So we have built, from our experience, CIP. So CIS is the ability to access the database. We here at EMA, we've built up CIP, and it is a fully built database structure that has an interface. You don't have to learn any database language. It has installers that will populate the database for you, create the schema, and build it right inside the OrCAD environment. You can create different roles. You can have, an administrator, and then, lower level users who can only do temporary parts. You can have automatic email notifications, direct access to DigiKey and other vendors right inside OrCAD. And we've integrated Silicon Expert into that space in our compliance module as well. So from our experience, engineers don't want to spend a lot of time building databases from scratch. So the CIP tool gives you a huge head start in having that environment built up and easy for you to make changes, populate it, and set up the way exactly that you want to use for your whole team. So for those of you who are new to OrCAD, we're inside our OrCAD X capture environment. And as I mentioned, all licenses of OrCAD X now include CIS with it. So here I have a design open, and we're going to emphasize for you how you now have these new features built right into OrCAD. So for those of you who are used to traditional OrCAD, you might be used to the place part, where you have to go find a part, and then you have to know the symbol name. You see the little preview of the symbol, right? And then you're working from each library that you point to and placing parts. So that means if you have another different value capacitor, you have to build another symbol and add it to your library, right? So a very, I'll say, individualized flow traditionally. With OrCAD X CIS, now you have the ability to place in that central database. So we're not just driving in data from those schematic libraries and building each part here one by one. We're building it from our central database. So this view here is a read-only view into my component database. In my example, I'm using CIP. Again, CIS does support, if you have a custom database and you want to do it that way. But it is a big time saver if you want to use our CIP tool to have a pre-built database structure. So you can come right in and you can organize your parts in the structure you want. You can create subcategories, and then you can see all the parts in your component database. I have my parts color-coded to see what parts are active, what parts are obsolete, what parts are used in current designs. And then when I click on a part, I can see here my part number, my symbol, my footprint, and then the manufacturing information as well right inside my database. So my user has so much more data when I'm using CIS because I can open up this data sheet. I can see the part is active. I can see the row house compliant. I can search and sort by any of these properties, right? Now, often you'll pull in things like, hey, this is a part that we have flagged to not recommend for new design. Hey, this is the operating temperature range for this capacitor. Your engineer has all of that data at hand, and you can search and sort by it. So if I double click on the value column, I can go and find all of my parts and go from smallest and then up and it understands those units, right? It can interpret them. You can see the data. You can find the exact part you want. And as I mentioned, you can use this tree structure, which gives you a head start in organizing the parts you want, or you can go and query and find the exact parts you need and have some pre-saved searches. I have a lot of 100 nanofarad capacitors I use a lot. They're 0603. I can see those part results saved right off the bat in my database. So this becomes the central area that your team comes in to look for parts. They don't need to each point to some library or point to some OLB on their own machine, right? Everybody looks in the same component database. You have the same field names. You have the same naming structures. You have the same manufacturer part numbers that you've populated in your component database to use in your designs. And this data maps down into your schematic and into your BOMs with CIS now. So when I double click a part, I can place it right on my design and have it ready. And I don't have to type in any of the information, right? All my capacitors use the same symbol. I can drop it in, and I can have the information be driven from my database into my design. So the description follows a format set in my database, the manufacturer part number. Again, there's no chance of me having the wrong field names because it is all dictated in my central database. So again, when you're using CIS, you're not looking out into some online database. We don't touch this data. This is your component database that you control. It's on-prem, it's your data, your parts. Only your team has access to this database structure. So as you build up your design in OrCAD with CIS, you will be able to standardize and find the exact parts you need. And then you can use that part manager to keep your design in sync with your component database. So let's say I come in here and I think, oh, I actually needed a 10 microfarad capacitor, right? If I come in here and manually change this data, it will actually order the wrong manufacturer part number, right? If I was to spit out this BOM. This kind of error could easily slip into my designs in the past with base OrCAD. But now with CIS Part Manager, I can launch that right from my project view to Part Manager, or I can go to Tools, Part Manager down here, and I can immediately have it check and scan all my parts in my design to tell me, hey, is anything out of sync? And I can see right away, hey, it tells me C18, this capacitor right here, you're claiming it's a 10 microfarad capacitor, but that part number is a 0.1 microfarad, right? All of the information is tied to that part number, not to the individual symbol. So if I hit yes, it would force it to match the database. But let's say I actually do want to use a 10 microfarad part. So I'll hit no, and I'll see all my results in my part manager view here. So I can see these are all my parts. These are all my part references. Here are all my parts. And I can check all of them again. The same part is still not in sync, of course. And all my other parts are green and matching, except this new C18 part is red. It is not current, right? So I can take this part. In traditional OrCAD, I have to delete this part, either build a new part and populate that symbol of all the right data, or I can come in now and do link database part. So you have all these commands in CIS Part Manager that allow you to really save time and do things in bulk. I can select this one part. I can actually select all my 10 microfarad capacitors here if I wanted to. I can link it and swap out the part data for it. So now the tool knows, hey, I'm looking for a 10 microfarad part. I can click on it, and right here in this little view, it highlights to you, hey, you're switching manufacturer part numbers, you're switching rated voltages, and that is what I want, right? I want an actual 10 microfarad part. I don't want to be just updating the one symbol and changing properties manually. So I find the part I need, and I just select it and link it, and it does all that work for me. It has the same symbol, so it's not going to rip up my symbol. It'll just update all the data, all the properties for me in one go, and push it right into my design. So this can be a big time saver, and this is the exact process you would use in your legacy designs. If you're going from no CIS into CIS, this is how you can now take your old designs and link them to these parts in your component database. So now, when I update all, I shouldn't have any parts out of sync, and I have the confidence that every part is green and approved and current in my database. So no more red parts. And if I was to go and look on this part of my schematic and hop over to it, now when I look at the properties, I can see that I have the correct description, matching a new manufacturer part number, one that actually reflects the kind of part I want to put into my board. So our customers who move into CIS have a lot more confidence in the boards they're pushing out because they run this part manager and they can see right within the tool that every single part is up to date and an approved part in their database. There is no properties that can sneak in. There's no footprints that can be assigned that aren't what you want. You drive all that and control and summarize all this inside the CIS part manager. Once you reach a state where you are confident in your design, you can come into your schematic now and you can push out this design into a BOM, right? I can take this design and now use the CIS build materials. Just to show you the comparison, in the traditional OrCAD flow, you would have to type in each of your header items. You have to know the property name, the property string, and you would have to manually create each of those new columns that you want to show up in your BOM. And there is no ability to create a template, right? Now with CIS, you can take this design and you can use this standard CIS BOM. And now you have the template built using any part, any property you want to search for. You can type that in here, filter it out. And you can see there's icons telling you where is that data coming from. Customers typically might not map in every single property from the database. So the blue properties are mapped to our schematic. And then this little cylinder tells me that, hey, this property we've reserved to only have kept in our component database. We don't need to pull it down to our design. So you can create the template. You can use these arrows to make it go up and down. And then you can have it show as many, and then as I'll show you in a little bit out your BOM as well with this template. And you can save as many templates as you want for different types of outputs that you want to see. And then when you generate this BOM, we call it a zero-touch BOM because I don't have to, fix it up. I don't have to move any of the headers around. It goes and follows the exact template I want, and it populates in the data. It shows me my alternate manufacturer part numbers. And here, the data I have in my database, again, comes from my database structure. So CIS gives you access to this, but whether you have this data or not depends on the actual database you have in the background. So in my case, I have CIP, so I'm able to grade for things like what year this part is predicted to go obsolete, what the current pricing of this part is, what the overall risk of this part, the approved, manufacturer alternates. All of that data is maintained by your component database, which CIS gives you access to, but it is not itself a database structure. So hopefully we're showing you the power of CIS, but now you have to make a decision. How do we want to build up that data? So all the BOM data is captured for you. You can get exactly the type of outputs you want, see your alternates, have them be graded, and have the confidence that your schematic is pulling the latest data from your centralized component database. So let's talk a little bit about variants now. So when you build a design in CIS now, with this design file here, you can now store variants in the same design. So I don't need to save 3 different copies of this DSN just to have a different output for, let's say, in Asia, I have certain parts set as do not populate. So here, C5, C6, C4 are set as do not stuff. And R13 is set to a different manufacturer part number. If I didn't have CIS, I would have to save this design as a different design name, maintain it separately. Here, I can maintain it all under the same design and have as many variants as I want. So I can have another variant where I have different parts set as do not populate, the resistors, and a different R19 that's set to a different value. All of that is done by the part manager, so I don't have to manually do any of those changes on my schematic symbol. I drive it all from part manager. I pick the parts I want to set as do not populate. I create these groups to apply the changes, and then it's all saved in one design for me. And I can take those BOM variants and output the exact BOMs I need. I can visualize those changes as well. I can go to View, Variant View mode down here and see, hey, what is it actually changing in my Asia variant? So when I come into this variant view mode, I can see the exact components up here, C5 and C6, that are set as do not stuff. It shows that visually on my design. You can view that for each of your variants. I'll go back to my core design now and show you that you can also generate a report. You can take your design and compare each of the variants against each other and show you what exactly changes. I'll compare all my variants to my core design and push out a report here telling me that C6 and C5 and C4 are set as do not stuff in my variant. R22 and R19 and R13 are set as do not stuff in my other variant. And then here, I can see exactly the changes. Here's a change in my description. And in this case, it's actually alerting me, hey, there is a change in your footprint as well for this component. So is this a variant that's acceptable? You know, some customers might say it's not because I'm changing footprints as well. For R19, it's not just swapping out manufacturer part numbers, it's trying to put a different package in. So now this is the kind of variant that most customers will not tolerate, and you can go and fix it in your part manager to actually make sure that it's the same board, you're just swapping out a different part of the same footprint, right? So those are the type of checks that you have gained in CIS as well. And as I showed earlier, you can take that BOM variant and you can use that CIS BOM functionality to call the exact variant you want. If you don't want it showing those do not stuff parts, you can uncheck this box. But I will show it for you just in this example so that you can see that it flags in the BOM the exact parts I have set as do not stuff.
Hey, Roger, while that's loading, I'll ask you a question about the design variants that came in. Can I show the value on the schematic, but show do not stuff in the BOM?
Yeah, so in the schematic, even though it says do not populate, I could actually have clicked on that part and seen the actual value as well. So yes, it doesn't wipe out all the properties. In the BOM, as you see here, C4, C5, and C6, it will just set as do not stuff, so you won't see any of the data for it. But in the variant view mode I just showed, when you click on that part either in the schematic or if you print it out as an intelligent PDF, you will see the actual part properties for C4, C5, and C6. So yep, the answer is yes, you can do that. So yeah, here's our BOM variant that we've pushed out, and you can see that change made to my BOM using the same design in OrCAD, but now for a variant of output, right? Good question. So everything I've shown you so far in CIS, it is predicated on the fact that you need a component database. So you gain a lot of power with CIS, you gain the ability to access the database, to check your design, to create variants, to create better BOMs, but you need a component database. So If you don't have one, you might consider building one from scratch, but we have a lot of experience helping customers use CIS with CIP, and that is our component database tool that we have built. It is a Cadence product where you can come in and actually manage a component database right inside of OrCAD. So you can see here is a new tab inside OrCAD, and I can come right in here and find any part in my database. I can create different user roles and see that, I have some users set to only be able to create, temp parts. I have other users only be able to create, be able to also modify formal parts, and then only, my admins can delete any parts in my database, right? So you now have a lot more control if you move down the CIP route to not only get the database looking exactly the way you want, but have a controlled process where your users can only, do things that don't mess up the database or your whole team, and the history of any changes are automatically tracked in the CIP database. So the CIS here that I'm placing from, all that data resides here in my CIP database. I don't have to go and learn some other database language or, do all of that manually. We have a database structure preset. And if I don't have a part in my component database, I can go right out to DigiKey from inside OrCAD, and I can search for that part and add it into my component database as a temporary part right up here. So I can come in here and search by keyword, or I can search by manufacturer part number, and I can go and find the exact part I want. And this is the live data, the same as if I go to DigiKey's website, and I can see right here the quantity on hand for each of my parts, the pricing for that part, and you can see the different packaging from DigiKey as well for the same manufacturer part number, right? So you can click on the part and actually have the data sheet, have the data map for you automatically from your component database, from DigiKey right into your component database. So you don't have to manually create any symbols now. We have the Ultra Librarian online CAD model library mapped right into CIP. So if I want to if I don't want to build any of those CAD models, I can go and download the symbol, the footprint, the 3D step model, and have it automatically map right into my component database. And you can see here, I can simply pick the table I want. This is an IC. I'm going to create a temporary part, and I can have it go out to Ultra Librarian and download those CAD models and map it to all of the data from DigiKey right into my component database. So when I hit add here, it'll create a new temporary part, and that part will be immediately ready to be placed down in my CIS as a temporary part. So your engineers don't have to wait if they want to create a new part. They can go and trigger that process, add it to the component database, it'll pull in the data sheet, pull in the manufacturing information. And again, all the attributes are standardized to your field names in your database, right? So you don't have an opportunity for error. Nobody's copying, pasting, nobody's typing in these fields manually. And all the parts are created and tracked in one central location in your temp part list. So I can see exactly the parts I have, all my temporary parts, whether they've been given an approved formal part number, whether a footprint has been assigned to them. This gives my team one area to work together, build new parts, and approve parts as well. So you're welcome to build your own database, but CIP is a huge time saver as well if you're brand new to the CIS space. And it has a bunch of bulk operations where you can bulk import your data. You can pull data from DigiKey. And then to wrap up, you can take this whole component database and you can grade it for obsolescence, for inventory. We have partnered with Silicon Expert to pull all of that data in so that you not only grade it, when you've built your design, when you're picking any part down, you can see when the end of life date is for that part, if there's any inventory issues for those parts. You have a whole database that is kept healthy and that you have confidence the parts are good to use on. So this is the best way to mitigate those board respins that are, so so many of our customers have to deal with. So here I can click right in and see here are all my high risk parts or high inventory risk. If I can't, purchase this part currently, I can go and have Silicon Expert recommend for me this Schottky diode. I can have them recommend a suggested alternate right inside my component database and see a report card of parts that are good to use and the electrical differences between them. In this case, I can even see, hey, there's actually an upgrade on this Schottky diode that the only difference is a better temperature rating. When you start stepping into the world of OrCAD X CIS, it can be more data to manage, but we have the tools to help you manage it better. And you have now all the capabilities to build up a healthy and reliable database to reuse for your designs. Thank you for your time today, guys. I will let Shannon.
Yeah, there's a lot of great questions coming in, so we'll try to get to as many as we can, and if we don't get your answer, we'll reach out after the webinar and follow up with you. So a few questions about the template for the CIS BOM. Can you make this global so all users can access it rather than create the template for each user?
Yep, yeah, that's a great question. So CIS, one of the key themes is that CIS, it gives you access to the database, but the template, the changes to how your tables might look in terms of columns and the part placement, all of those are saved to each local client machine. So the answer to that question is the templates I see here when I go and create a CIS BOM, these are local templates to my machine. If you want to reuse templates on a team basis, we've actually built that functionality into CIP. So CIP has a BOM output as well here. And that can be really powerful because now you can have templates for your whole team and you actually gain the ability of where used. I can see for this Schottky diode that I just saw was high inventory risk, I can see exactly which of my BOMs are using this part number. So you have a where used to say, hey, we just heard that this part can't be bought. We're going to have to fix up these boards because it's used in those BOMs. So there are some BOM capabilities in CIP that allow you to do team templates and track where parts are used. Great question.
A few questions came in on the highlighting of the rows in your CIS database. So how do you do that? And is it done manually or a setting?
Yeah, so in CIS, you gain the ability to see your database and see all the parts within any folder, right? To color code them, we actually did build that as an additional, I'll do my capacitors just to show you the color coding. We did build that as an additional little app called our EMA toolkit. So it will color code these parts based on any condition you set. So if you're part of our EMA customer base and you have access to our support team, you will be able to access this EMA toolkit. It has a bunch of really handy features, including this CIS row color app, where I can save some rules, I can set different conditions, and then use it for my whole team so that anytime I see a part that is obsolete, it'll flag it in red, right? Let's see, yeah. So here my red obsolete parts, my green active parts, my yellow not recommended for new design parts. So it is a app that we have built as part of our EMA toolkit.
I did put the link to the EMA Support Plus in the chat. So if you need more information on that and the apps included in it, feel free to go to that link. As Roger said, it is free and available for any of our EMA customers on active maintenance. Let's see. Is there a starting structure that can be used to build a database?
Yes, so CIP provides that database structure, and it provides you these tables. You can rename, add to them, and each of the tables will have fields specific to it, right? Diodes, you'll have, if you have the LED color, you might have the, maximum reverse voltage. You won't have those fields for capacitor, right? So CIP gives you the database schema and the database fields as part of that license. If you don't have that and you're building your own database, you will have to create your own schema, your own tables, your own fields. If you want alternate manufacturer part numbers, your own relational table. So
and add on to that, what about the extra properties that your company might need? Are those customizable in your database? Can you add them in?
They are. Yeah, they are. So CIP gives you the ability to add and customize as many additional tables as you want inside your database. So I can come here as I'm an admin for my database. So I can come in and configure not only what tables I have, but I can customize and add and rename any fields I want in my CIP database per table.
Great. Okay, which supplier APIs are compatible with the CIP and CIS database? I know you showed DigiKey, but did you want to go over the others available?
Yeah, so we have partnered with Arrow, DigiKey, Future, Mauser, and Newark as the APIs for their data. So again, even if you don't purchase from them, this is a great starting point because as I showed you, you can come right in and look for a part using their data, pull in their data sheet, pull in their parametrics, and then map it to an ultralibrarian symbol, right? So we have partnered with them here. If you do have additional vendors that you want added, we can look into it. It's a two-way partnership, so we don't always have to say to whether we get access to that API data. And on the topic of API, as I mentioned, Silicon Expert is another huge source of data. You get great data from DigiKey and other vendors. You get 10 times more data with Silicon Expert from the same manufacturer part numbers.
Great. And what type of database is being used for CIP, and what other do you have to use that database? Is it compatible with others, and what tools can be used to edit it?
Great. Yeah. So CIS gives you access to any database using an ODBC connection. So that's a pretty standard connection to a data source. That means that you can use, a Microsoft SQL database, which is what CIP is based on. You can build an access database and point the ODBC to that. You can build some other, SQL database using a custom, implementation yourself and point to that. CIS gives you that flexibility. All of those flows will give you the CIS functionality, right? The place database part manager, and the CIS BOMs. But having the interface inside of CIP or to access the database directly inside OrCAD, only CIP can do that. So that is a big advantage of CIP over a custom database build.
Is it possible to migrate existing central databases from other CAD tools?
Yes. So we have actually a lot of experience at EMA. we do offer service projects where we will take other CAD tools and bring in their data into CIP, into CIS. And if you need help with translation services, we can help with that as well. But CIP has a bulk importer, so you can take all of your data and map it in and do one push and bring all of your data right into CIP, and then that gives you that data right inside CIS as well, right? CIP is the back end of CIS in this example.
And I think we probably have time for one more. I use CIP under previous versions of OrCAD. Do I need any new version of CIP to use with OrCAD X?
So we keep CIP up to date with all the latest Cadence versions, and we've actually made it really flexible. The CIP you're seeing here can actually support the latest OrCAD X, which is 24.1, all the way back to 22.1. So we support CIP. One CIP database can be used for different versions of OrCAD at the same time. So the answer to the question is that it depends how old your CIP is, right? We have a lot of experiences helping you take your CIP and bring it up to date. It's typically a pretty straightforward install for that. but you should always keep your CIP and your OrCAD software up to date, because we add in a whole bunch of new features with each CIP release. Things like the mapping to Silicon Expert, the mapping to the distributors. Those APIs get updated, so we update CIP to match those changes.
Great. Yeah, it's always important to get up to date so you can get those latest features and use the new functionality that's released. Maybe we have time for one more. Will the BOM show high lead time parts?
Yes. So if you have the Silicon Expert subscription with CIP, when I look at a part, I can actually see, let me pick a part that is active. I can actually see a part that is the exact lead time, and Silicon Expert gives you the min and max lead time for those parts. So here, I'll pick a part that is fairly long, years end of life. And let's see one of these ICs, this TI part in this case. Silicon Expert, and actually DigiKey supplies it as well, but when you come down here, you can see the exact, well, not in this case, I'll use Silicon Expert, but the exact lead time, the year, the end of life. But way down here, you'll have lead time as well for the min and max lead time predictions right here. So I can see 6 weeks maximum lead time for this part, and actually minimum as well, the average pricing, average inventory, and you can see how much is carried by different vendors as well. So all that data here will show up in your BOMs. If you pick these as BOM columns, your CIS will be able to pull this data right into your BOM.
Great. Thank you so much, Roger. Unfortunately, we are out on time today. I know we didn't get to all of your questions, so we will follow up with you after the webinar is completed. We also be sending out the recorded version of today's webinar. So thank you again for taking the time to join us today. Have a great day.
Thank you, everybody.